Hey kids, Flexing Teacher Weber here. I'm going to do one more problem from this page, and then I'm going to give you some to try. So we've done two problems so far. I want to jump ahead to number 8. It's a question about Egyptian pyramids. So let's read the question. It says, the base of the pyramid of Khufu is a square with sides 230 meters long. Calculate the length of the diagonal of this square to the nearest tenth of a meter. All right, so in this problem you have to imagine that you've got a bird's eye view of the pyramid, and if you're looking down on the pyramid, that the base of the pyramid or the bottom of the pyramid is a square. So we're going to draw a square with sides 230 meters long. So I'm going to flip ahead here, and we'll call this number 8. And so the base of this pyramid is a square, so I'm going to draw a square with sides 230 meters long. That means all 4 sides of the square are 230 meters. Guess I don't have to label it all parts, but that's okay. So square has all sides equal length, so that's 230 meters. That's quite a huge distance, by the way. That's like 1/5 of a kilometer. So this is quite a large pyramid. Now, let's go back to the problem. It says that calculate the length of the diagonal of this square to the nearest tenth of a meter. All right, so diagonal. So that's exactly what it sounds like. The diagonal of a square, there's actually 2 of them, and it goes from one corner to the other. So I'm just going to draw on one of them. So a diagonal could go, that's not very good. That's not very good. Sorry, I'm having some trouble here. There we go, that's better. Diagonal goes from one corner to the other. So what you can see here is we actually have 2 right triangles, right? I'm going to indicate the right angle right there, right? There's the right triangle. So if that's the right angle, then we know this leg of the right triangle, we know this leg, but we want to figure out the length of the diagonal. So the diagonal represents the hypotenuse of that right triangle that we made, or the both right triangles. So there's the hypotenuse x. So if I was to use the Pythagorean theorem to figure out the diagonal of that hypotenuse, diagonal of that right triangle, it would be square of the hypotenuse equals 230 squared plus 230 squared. Working down the page, x squared equals 230 times 230 is 52,900. And we have to do that twice, plus 52,900. When I add those up, I get 105,800. Now that's what x squared is. We want to know the value of x. So I will take the square root of both sides, and definitely using a calculator to get this. The square root of x squared is x. 105,800 is not a perfect square, so this will be approximately 325 3/10 meters. Make sure I get my decimal in there. So that hypotenuse is 325 3/10 meters. That's the length of that diagonal, and that should be the longest part. Now, this is a really interesting problem for practical use. Let's say you're trying to put something into a rectangular box or a square box, and it won't fit. Let's say you're wrapping a present for someone, and you're putting that present into a square box or a rectangular box, and you just can't quite get it to fit. Try putting it in diagonally, because the diagonal of any rectangle or square is the longest part of that. And you can see in this problem, it's quite a bit longer, right? It's 100 over 100 meters long, or just under 100 meters longer than the two sides. So that's quite a distance. So this is how you use, you solve problems using the Pythagorean theorem. You draw diagrams, you look for that right triangle, and then you use the properties of the Pythagorean theorem to solve. So I'm going to give you some problems to try, and this will be the last section we do in this unit before we have a test, but you'll have a couple days to work on this. Make sure you have watched both videos, because that should give you all the information you need to solve these problems. That's all for today. Flexing Teacher Weber, out.